Hi, this is the practical demonstration of the task 5.1. As we can see, the class named is wLinkList, and the nested class, that is a node inherited from the inode, that is the program is it over here. And we can see that next pointer, previous pointer, and k value is the parameters which is being initialized in the constructor. And we see this public override string method, which is actually override to string method, which converts the list to string. This is head and tail. And as we can see, the constructor of wLinkList, the outer class in which we have initialized head and tail, and head node next is equal to tail. So this method is returning the first element in the list, and this method is returning the last element in the list. So if we have a look at this one and the after one, we can see if a node comes in parameter, this node that is coming into the parameter is null, it checks over here if it's null or not. If it is null, it throws a null reference exception, else it will add up in the given node if it's not null. What actually is happening over here is that the node that is given, that is being sent into the parameter, it checks if the pointer to the previous node, it checks if it's null, and if the node underscore current node next pointer is null as well, then it throws invalid operation exception, means the node referred as before is no longer in the list. So this is how this particular function is actually checking if the node that is coming into the in as the parameter, and it's pointing the previous one is null, and if the next one is null as well, then it throws invalid operation exception. The method add last, which adds given value as a node to the end of the list. It just adds add between. This add between is a function which is this one is being used, and a value t is being sent as the node of the value t is being sent into the add last, and then add between is a function being used to add given value as a node to the end of the list. This is add between, value, previous, and next are being sent into this as a parameter, and then what it does is, again, it is just in which value, previous, and next is parameter. It adds new node containing this value between previous node and the next node. So this one is find method to find this value in list or not. It just check if the value is this value in list or not, the node of this value is in the list or not. You can see the toString overridable method for printing out the list. The before method, it returns the node which is coming in as a parameter. It returns a node which is present before parameter node. First we check if it's null or not. If it's null, then again it throws the null reference exception. For the node that came, we check if it's the previous and the next is null or not. If both are null, then again we do the same thing that we did before, no longer present in the list. Then invalid operation exception is thrown. Next node is tail, then return null, otherwise we return previous node of the parameter. We are throwing the previous node of the parameter. Add first is actually add node containing this value we use. Add between function value will be placed between these. Again, this value, the node of this value will be placed in the this function will be used, add between, which we have created in the start, is the will be added in the head.next and head add before. What it does is it adds a node containing this value, which is the parameter. Before this node, we check if node if the node is not null. If it's null, then we again throw exception, argument null exception. We will a new node. Sorry. So it adds a node containing this value, is not null. It's again is just checking if the node is not null. If it's not null, then it throws. If it's is null, then argument null exception is thrown. Again, it's the same thing happening, just that like we did before. Is check node comes up, if not null, if null, then throw exception, argument null exception. We will new node in current, that is before node that came in the parameter previous, and the next pointer of this node, if they are null, means it's not present, then throw invalid operation exception, just like we did before. Otherwise, we check if current node is head value, because head is the pointer. If it's first, we make add between and add value between in first place of the list. Else we will again see if the previous node will be node current given, and this will be added between over here. Then we see then we will see the add after function, which we can add after this node pointer. Again, this node pointer, this node. The parameter node of this value, check if not null, we create a new node for parameter, check previous and next pointer. If they are null, then invalid operation exception is thrown. Otherwise, return add between value in the parameter, because we are gonna add it after this one. Clear method is used, in which we clear the whole list, created a node from tail.previous. Method starts from tail. The cleaning method actually starts from tail. It starts while loop while node becomes head and node until be nullified. That is to move back to the previous node. Head and tail as new node, and tail will be the head underscore next underscore tail. So the remove the parameter node, it again does the same thing that we did before. It check if null, check if it's null, then throw exception. New node, then new node current is made, just like that. Then we check if it's null, both next and previous. If, then they threw invalid exception. Then we check if node to be removed is head node, that is head. Next, if it's head, then it's more easy to remove it. So the next value to the value to be removed will be head, node current is removed. So, and then the counter is decremented. Else we check if it's a tail. Over here, if we check if it's a tail, then of course, so we will make the tail the value before the value to be removed. That is node current and previous. The node current will be nullified. And then the current count will be decremented. Else, if it's node head or tail, which is this part, else if it's node head or tail, then we will create a temp node in which we will store the previous node of the node to be removed. That is node current dot previous. Then read, then we just read this one, and then node current dot previous dot next is set to node current dot next, and then this temp, which we created a new node for this one and stored into the temp, we will assign this value to node underscore current dot next dot previous. And then the node current next previous will be temp, which is the stored value, and the previous and the next of the node to be removed will be nullified, and the counter will again be decremented. Remove first and remove last is used up over there. Remove first is when we remove it from the head, and remove last is when we remove it from the tail. This is the code that we used, same thing we used over here. If it's head, then we use remove first. If it's tail, then we use remove last. This is just the way of removing the list. Removing, if we want to remove from last, then we use tail previous, and if we want to remove from first, we use head next. And I can just run this code to make sure if it's running and show you. As you can see, this code is running.